Okay, are we on the internet? Looks like I've got levels. Looks like we've got recording. Looks like we've got streaming. And I think we are on the internet. Looks great. All right, folks. Welcome to yet another installment of Flight School Academics with good old Foghorn. On this, the 1st of September, where in the world did August go? So, this is a presentation as part of an ongoing series of academics for the members of the Aurora Republic, a premier role-playing organization in Star Citizen. If you are new to the Aurora Republic or visiting for the first time, let me start by saying welcome. We are glad to have you with us. Would love to hear from you if you are interested in hearing more from us. We are a lawful good organization focused on roleplay, exploration, and social interaction, are currently actively recruiting on Spectrum and Discord. Before I get to tonight's presentation subject, let's go over the rules of engagement. We are streaming this video on Twitch, and I am simulcasting my voice in Discord as well. We are streaming this in Twitch, so if you do have a mic muting error, you're going to be transmitting out over the internet. Everything that's going on in your room, we'll be able to hear it. We'll be able to hear it, and we will make fun of you. I'm kidding, of course. So there's an 8-second delay between when I say something and when it comes out on Twitch. So if you are listening up in both, I would suggest you mute Twitch, so that you're not hearing me twice. It's probably painful enough to have to listen to me once. Anyway, I will be monitoring the Twitch chat as best as I can, and also in Discord. So if you have a question, you can either, of course, post it in the Twitch chat, or you can just come up in Discord and tell me there. All right, we have a big subject, but it actually is going to go very fast because I'm not going to use any mathematics. No math tonight, just concepts only. Galactic navigation. Basically, I'm going to go over I'm going to very quickly overview celestial coordinate systems, and then more importantly, we're going to go over the Galactic Coordinate System, which is one of those celestial coordinate systems, and it's the one that apparently is being used for Star Citizen as far as I can tell. So, let's get our celestial on. Basically, all the different variations of celestial coordinate systems are all based on spherical or a type of coordinate system known as spherical coordinate system. The components of those is they have an origin point, which is of the center of that system. They have a primary direction, which is what you would recognize as 0 degrees longitude. A fundamental plane, which you would recognize as 0 degrees latitude. Of course, 90 degrees off from those would define the poles coming out from the center point and perpendicular in all directions to the fundamental plane. And those combination of things end up giving us a set of coordinates, a triplet of a latitude, a longitude, and then also a range to be able to locate any object out in the heavens from that origin point. The systems also have a convention based on whether they are right-hand or left-hand circular. That is defined at the center point with the thumb using your hand, using the thumb pointing up at the North Pole, and then which way does the longitudes increase. If you put your left hand on the origin with your thumb pointing up at north, and the bend of your fingers is in the way that's going, that the longitude is increasing, will tell you whether that is a left hand or a right hand system. So here are basically the 5 different celestial coordinate systems that are in use in various different sort of genres, if you will. Horizontal, equatorial, ecliptic, and the supergalactic. The galactic coordinate system is the one we're going to be talking about in the second half of this presentation, so I'm going to skip over it during this interview because we're going to hit that one actually in depth. So this little table summarizes all of these things. The horizontal coordinate system is actually based at the observer. This is typically what folks will use who are amateur astronomers, where it's based. The center point is based at the observer. The fundamental plane is out to the horizon on the Earth. The poles are the zenith and the nadir. In other words, straight up out of the observer's head, or straight down for the nadir out of the observer's feet. And the coordinates are given as an altitude and an azimuth, or an elevation and an azimuth. Altitude and elevation in the horizontal system basically is synonymous. And the primary direction, known as zero longitude, is north, or can also be derivated from a south point if you're someplace where the north point, aka south hemisphere. That convention is actually left-handed. It's the only one that's a left-handed convention. Basically, all of these four that I'm going to briefly cover right now all have a variation to them that I'll talk to in a minute that makes them not the best one to use for what we're talking about. The equatorial system is centered on the Earth. It's geocentric, and therefore the equator of the Earth, that's why it's called the equatorial system, is projected out into space, and that is defined as your fundamental plane. So the celestial equator is basically the equator of the Earth projected out into space. Celestial poles are the same thing. That's the Earth's poles projected out into space. And the measurements, or the coordinates, are in declination and a right ascension, also known as an hour angle. The zero direction is the vernal equinox. So, which also shares, the equatorial system also shares a lot of components with the ecliptic. And the ecliptic actually has two sub systems in there, based on whether the ecliptic system is based on the Earth or is based on the barycenter of the Sun. Barycenter means the center of rotation of our solar system, which is very close to being the center of the Sun, but is not actually the center of the Sun. The actual center of rotation for the entire solar system, when all 9 planets are taken into account, is actually off-center, because the gravity of the planets also work on the Sun the same way the gravity of the Sun works on the planets, and that's why the Sun will wobble. That's also how we can look out with something like the Hubble Space Telescope, see a star a long ways away, and even if we can't see the planets, we can guess that there are planets if we see that star wobbling, because it's not rotating directly around its own physical center. It's rotating around a center of gravity, and therefore that center of gravity is off from its center of mass slightly because of the pull of planets that would be around it. The ecliptic plane and ecliptic poles are based on the fundamental plane that is traced out by the motion of the Earth. In other words, the Earth orbit around the Sun defines a plane. That plane is basically also roughly the same plane that all of the other planets orbit in. There is some small variation in there. I believe Mercury has a slightly out of plane in its orbit. But that is the ecliptic plane that goes out and is projected out into space. Obviously 90 degrees off from that, from whichever center you're using, whether it's the Earth center or the Sun center, is your ecliptic poles, and then you have latitude and longitude that are based off of that ecliptic plane. It's also zero direction longitude is the vernal equinox. Okay, supergalactic is actually pretty heady stuff to try to get your brain around. When you sum up all the positions of what galaxies we can observe from Earth, right? So this is a huge thing, because you're talking about creating a coordinate system for all of known universe, and that known part's important, because if you have a known universe, that means that there's a whole section of the universe that you don't know, the unknown portion. So if you sum up sort of all of the positions of the galaxies that we can observe from here, they generally can sum up to create a supergalactic plane. There's an average planar surface there that can be mathematically calculated, as can the poles, and therefore also a galactic latitude and longitude. Now, the origin is obviously an average of all of these positions. And using galactic coordinates to describe where the supergalactic center is, it would be at a galactic longitude of 137.37 degrees and a galactic latitude of 0. So, oh, by the way, the primary direction, the 0 degree longitude, is where the supergalactic plane and the galactic plane that I'm about to talk to here in 2 slides intersect. All of those systems are all right-hand. They're all right-hand oriented, right-handed circular. Now, there's variations in why these don't make them the best to be using for a large within one galaxy space game, right? So the horizontal coordinate system varies with both location and time. So being on a spot in the surface of the Earth and going, okay, I want to figure out where, that star is so I can point my telescope at it. You not only have to know where the location of that star is, your coordinate system is relative to that spot on the surface of the Earth at a specific location and a specific time, both time of day, season of the year, date, the whole bit. So this is makes things a very unwieldy if you're doing anything else other than just trying to do, amateur astronomy. The equatorial system varies with nutation, and nutation is a wobble of the Earth's poles. The Earth does not actually, the poles of the Earth are not, welded perfectly in space. The Earth's poles actually wobble a little bit, very slightly, it's called nutation, which then means that any set of equatorial set of coordinates will also vary by time, but it'll be by a time epoch, which creates a whole bunch of ugly math that you have to do, all kinds of trigonometry to be able to figure out exactly, okay, well, this set of coordinates you gave me for where that star is out there, it again is based on time. The ecliptic has the exact same problem as the equatorial, but now if the ecliptic is centered on the sun, it's not the Earth's nutation that becomes a problem. It becomes a term that's called perturbation, which is variation that happens within our solar system based on gravity acting on the solar system from large objects outside of it, where it can actually vary the motions of our solar system as well. Again, what that means is that time becomes a factor in your coordinates. Your coordinates now have a time factor to them. You don't just need to know the coordinates. You have to know what time those coordinates were referring to, because and they all have to. The way you get around that is you have to reference a common epoch. Again, could create very ugly math. The last one with supergalactic is the variation is the fact that we don't know how big the universe is. So as we discover more galaxies and everything, we keep having to recalculate where the center of the supergalactic system is and where the fundamental plane is. So that one's really ugly unless you're forced to use it because you're looking supergalactically. Okay, so what's the one that appears Star Citizen is using, and why the Galactic Coordinate System, which some people will call geeks, GCS. The reason why I think this is the one that they're using, one is because it makes sense, and two, because of this latest ship offering, the Crusader Industries Mercury Star Runner, their medium data runner ship. And their little mini game that they actually had you go out, and if you found the belligerent duck, then you had to put in in the little mini game was you had to report the galactic longitude, galactic latitude, and the range distance. So that right there, I think, is a pretty big tip of the hat that they're just using. That they're actually using a proper spherical system, aka the Galactic Coordinate System, and they're not trying to cheat with some sort of a three-dimensional Cartesian coordinate system, which could work, but could get very unwieldy very quickly. So, geeks, the Galactic Coordinate System's origin point is the sun, our sun, Sol. The primary direction is a line running from Sol right back to the center of the Milky Way galaxy. That line is the 0 degree longitude line. The fundamental plane is based on averaging the positions of all of the stars in the Milky Way galaxy, and you will find that they basically come out, and the average of that creates a galactic plane. You can actually see this, by the way, and I'll show you a picture in a minute. Going straight up out of the sun, north and above 90 degrees up and 90 degrees down from the galactic plane, it will be the galactic poles, and therefore you can get a galactic latitude, longitude, and a range. And this is a right-hand system, and it does not vary with time, which is why it is it's the best system to use when you're talking about navigating the stars within the galaxy. So looking from God's eye view down on the Milky Way galaxy, wouldn't that be fun? So as you can see, let me see if I can pull up my magic laser pointer, pseudo laser pointer. Whoop, there we go. Okay, so here is our solar system right here, the sun, out here on the Orion Spur arm of the Milky Way galaxy. So from the sun being the center, if you draw an imaginary line going from the sun through the center of the Milky Way galaxy, that is the 0 degree longitude line. So if you take the heel of your hand and place it down on the sun and point your fingers up the 0 line of longitude with your thumb pointing back up out of the screen at your face, and then let your fingers naturally curve, with your right hand, you'll see that this is a right-hand system. You'll notice that the longitudes count up as they go around counterclockwise. So here's 30, here's 60, here's 90. That is a right-hand system. And as you can see now, we have range. So right about here from the sun, coming out the 180, that's 15,000 light years. There's 30,000 light years to the near edge of the Milky Way galaxy. And if you go the long way across, out the 0 line, the far edges are roughly 75,000 light years. I hope you feel small, because we are. Anywho. So we'll show you some other things. So that's the center, primary direction. And then, so this picture right here is actually an infrared 2-micron telescope picture from planet Earth, looking straight back at the center of the Milky Way galaxy. So your eyeball right here is basically looking up that 0 degree longitude line. And as you can see, this entire scatter plot of stars in the Milky Way galaxy, their deviation north or south from the fundamental plane, if you sum that, it actually mathematically creates a fundamental plane. And your eyeball can actually see this when you're looking outside, and you see the fact that if you're away from light pollution and you can see the Milky Way through the sky, you're actually looking at the galactic plane for this system, which traces to about there. Go 90 degrees up and down from that, straight out of the top and bottom of Sol, and you get the north and south galactic poles, which then allows you to be able to give galactic coordinates. So galactic longitude, so here's the sun, there's the center of the Milky Way galaxy, and as you go left-handed and measure the degree angle, that gives you your longitude, which is as a lowercase l, and then how far it is up or down from that galactic plane is your galactic latitude, and that is a lowercase b, as in Bravo. And then you define range as that distance out. So you get your triplet for your coordinates. Now, from sitting on planet Earth, if you're looking at Coma Berenices, also known as Berenice's hair, that's what Coma Berenices means. The galactic North Pole looking from Earth is basically just about here inside the Coma Berenices constellation. Is the word I'm looking for. Yeah. You want to go south, you got to look near Sculptor constellation, and there's the galactic South Pole. Probably hope to be in the southern hemisphere to see that. The 0 degree longitude, it actually is pretty easy to see as long as you're not near a whole lot of light pollution, because you can actually see the Milky Way. So if you look back at the fattest, milkiest part of it, you're looking right back at the 0 degree longitude towards the center. But as far as constellation goes, this constellation you see around the edge, that is Sagittarius, the constellation Sagittarius. So it's basically, here's the bottom edge of his bow, here's his body and his legs down here. So it's basically right down underneath his armpit, halfway between the bottom edge of his bow and I guess that's a hip. Excuse me. And if you want to look the other way, away from Galactic Center, you want to go to the anti-center, in other words, the 180, if you look and find the constellation Auriga, then, which is this constellation right here, it's actually just a little bit outside of it on the long flat edge and a little bit down. So there's an actual photo. All right. So like I said, just a quick review, just concepts only, no need to do math, just so you know where this all came from. So sun's the center. Back through the center of the Milky Way is the 0-degree longitude. It's left-handed, or excuse me, it's right. It's a right-hand system, so it counts up counterclockwise. The average of all of the vertical coordinates, if you will, the polar north and south coordinates of all of the stars defines a plane that is the actual disk of the galaxy, and that's your fundamental plane. And 90 degrees from that is the poles, and that gives you your triplet of coordinates: a galactic longitude, a galactic latitude, and a range, probably measured in light years. So, alrighty. So that wraps that up. Are there any questions that you'd like to ask before I do the outro and we go fly? I actually have a game we're going to play in Star Citizen here in a minute. I'll give you guys 5 seconds or so to pop up and fire off a question. Okay. Silence is consent. That wraps us up for this installment of Academics with Foghorn. I hope you found it interesting and helpful. If you have any questions I didn't answer, please feel free to contact me via email, Discord, Spectrum, or the comment section below. I will answer to the best of my ability and as quickly as I can. If you are part of the Aurora Republic membership and haven't hit subscribe or follow on Twitch or YouTube, then please hit it immediately and enable your notifications so that you know when we're putting out some new content. If you are a visitor to this channel, then please feel free to hit the subscribe or follow buttons as appropriately also, and your feedback really does help us as we're all striving to improve our content. You can find out more at aurorarepublic.space or on the RSI website at robertspaceindustries.com/AuroraRep. And if you are watching us on YouTube or Twitch, then you obviously know how to find us already. So I'll see you next time. This is Foghorn signing off, wishing you a pleasant remainder of your afternoon, morning, evening, or whichever time epoch you choose. Thank you very much.